Hello, this is Nicholas. I'm back. I had to go, and now it's 2 days later, but I'm back. So, we were doing the third one, and let me see. It was which of the following are true? They gave 4 different ones. The first one was cosine of 2x is equal to 1 minus cosine squared x. And all these were seeing if they're true or not. The second one was sine 2x is equal to 2 tan x cosine squared x. The third was cosine of 2x is equal to 1 minus 2 sine squared x. And the fourth one, I should have just done numbers instead of Roman numerals. Fourth one is tangent of x is equal to the square root of secant of x minus 1. Now, when they say true, it's important to make the distinction in your mind. They mean always true. In other words, I'm sure that these particular identities that they've given are true for some particular value of x, but are they always true for, are they true for all values of x is what they are getting at here. They want you to make that distinction in your mind. So now the first one. If you recall, cosine of 2x, the usual formula you have for it is cosine squared x minus sine squared x, which you can simplify in a couple of different ways. You can make it cosine squared x minus 1 minus cosine squared x, because sine squared x is 1 minus cosine squared x, which will give you 2 cosine squared x minus 1. Or you could have made it 1 minus sine squared x minus sine squared x, which is 1 minus 2 sine squared x. So you've got this form, and this form for your 3 different versions of cosine of 2x. So right off the bat, we know this is false. We know this is true, and that's all we can do with that first one there. Now the second one, we know sine of 2x, this one only has one version. All of them only have one version, except for this cosine 2x here. Sine of 2x is 2 sine x cosine x, and 2 tan x cosine squared x is 2 sine x over cosine x times cosine squared x. And one of these copies of cosine x is going to cancel with one of those copies of cosine x, leaving just one cosine x left. So we're going to get 2 sine x cosine x, which is true. So this is true. Now the fourth one, I don't really like this radical here, so I'm going to square both sides. I'm going to get tangent squared x is equal to secant x minus 1. Now I know tangent squared x is secant squared x minus 1, because 1 plus tangent squared x is secant squared x, so I just subtract 1 from both sides. Now hopefully you can see right away that this is not true for all values of x, but I guess to make it a little more concrete, what I'm going to do is I'm going to factor the left side into secant x minus 1 times secant x, secant x plus 1 is equal to secant x minus 1. Now, and I can do this because this is the difference of squares. It's secant squared x minus 1 squared, because 1 is 1 squared, which is the difference of squares. Now, traditionally, okay, secant of x has a value of x that makes it equal to 1. In other words, it is true that secant of x minus 1 can be 0 for a particular value of x. So technically, I can't divide both sides by secant x minus 1 because for a particular value of x it can be 0, and that would be dividing by 0, which should be again another clue that this is already not true, that secant squared x minus 1 does not equal secant x minus 1 for all values of x. But if you excuse that particular instant, because it is only one instant, if you're considering only one period, I am going to divide both sides by secant x minus 1. So that's going to go away, and then that's going to become a 1 because you're dividing by itself. And you're going to get secant x plus 1 is equal to 1, or secant x is equal to 0, which is never true. So if at all it wasn't clear to you at all, it should be blaringly obvious now that it is not true. So false. So, and the question asks how many of these are true, so you would put 2. That was the answer for that one. Now I have, I don't want to save this. Now I have one more that we didn't quite get to, and I think it's a very important one because they tend to ask this a lot. So, alpha and beta are third quadrant angles. So in other words, if they're third quadrant angles, another way that they will say this sometimes is that pi is less than or equal to alpha. That should be, that's really an alpha, not an A. It's an alpha or beta, which is less than or equal to 3 pi over 2. In other words, there's these two things here say exactly the same thing. Just know what they mean when you see either one. They're saying the same thing. Okay. Such that sine of alpha is negative 4/5, and cosine of beta is negative 5/13. We want sine of alpha. That's a horrible alpha. Alpha plus beta. That's what we want. We want sine of alpha plus beta, given all this is true. So now I'm going to kind of draw separate triangles for each one of these, because they are separate triangles, because they're forming different angles, because the sines, well, one, because they're different angles, alpha and beta, and two, because the trig functions of those angles are different. So if we're gonna draw one triangle that has has a third quadrant angle alpha, and the sine of that angle alpha gives us negative 4/5. So that would look something like this. So now we've got our triangle like this. Along here, that is our angle alpha. I just drew an arrow, but that angle right here is our angle alpha, and the sine of alpha is negative 4/5. So this is going to be a negative 4, and then that's going to be a 5. And the reason why this particular side is a negative 4, this leg, rather than the hypotenuse, is because it's downward, right? If you imagine this is an xy plane, this is your y, this is your x coordinate, you're going down 4 along your y-axis, so it's negative 4. And your maybe I should write this down because it is very important. Sometimes they'll get you on this. Sometimes your radius is always positive. It's always positive. So, and the reason why that is because you know, if you imagine a circle along here, right? Because we're really on some sort of circle. You know, it doesn't necessarily have to be a unit circle, but we're on some circle here because we're taking the trig functions. A circle can't have a negative radius, right? That doesn't make sense. Distance is a positive quantity, but you can go down along the y-axis. So that's why your x or y legs here or here are always going to be the ones that you know, deal with these sign changes. Okay. Now, so this leg is -4, the hypotenuse is 5, so the distance of this leg here must be -3, and it's a -3 because we go to the left along the x-axis. Now, that takes care of that angle, or that triangle. Now we have another triangle such that the cosine of beta, and again it's still a third quadrant angle. Now we have another triangle beta, so this angle here is beta, such that the cosine of that angle is -5/13. So the radius is always positive, that's a 13 there, because cosine is, you know, if you're talking about SOHCAHTOA, you know, it's adjacent side to that angle over the hypotenuse. So that's where I knew to get those lengths from. Now, the adjacent to this, the adjacent side to that angle beta is this side here, and since we're going to the left, it's a -5. Now you can use the Pythagorean theorem, or maybe you're just familiar with the 5, 12, 13 triangle, but if you were to use the Pythagorean theorem, you'd get that this side would be a -12, and again it's negative because you're going down along the y-axis. And you can check that for yourself. 5 squared plus 12 squared does indeed give you 13 squared. Okay, now we know sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So we just need to find those values, which we know from these two illustrations here, so we can find what we want. So we were given sine of alpha is -4/5, so -4/5 times the cosine of beta, which we were given is -5/13, plus, now the cosine of alpha we weren't given, but we can find. We know, and I'm looking at this left illustration here, we know that the adjacent side to this angle alpha has a side length of 3, and we know the hypotenuse is 5, so the cosine of alpha is -3/5. And now the sine of beta, now I'm looking at this right illustration here, we know the side opposite to the angle beta has a length of -12 divided by the hypotenuse, which is 13, so sine of beta is -12/13. Now we just do some clearing up here. We're going to get 20 over, what's 5 times 13? I think it's 65. 65 plus 36 over 65, which is going to give us 56 over 65. That's it. So, oh, one more thing I did want to say is sometimes they'll ask for, you know, something like secant. They'll ask for secant of alpha plus beta, and you know, maybe right away you're thinking, well, whoa, there's no identity for secant of alpha plus beta, at least off the top of your head. You know, we gave you identities for sine, cosine, and tangent of alpha plus beta, but realize that, and it would be kind of mean for them to ask this because it would turn into just a lot of messy arithmetic, but you know, secant of alpha plus beta is just the same, one and the same as 1 over the cosine of alpha plus beta, which we know. So if they give you the other 3 trig functions, the traditional trig functions, you know, these ones over along here, that you don't know, you can just write them in terms of the ones you do know. And I think that takes care of everything. If you have any questions, if you're actually watching it this far, then I would love to answer them in the practice, because this is a very important topic of mu tests. It's probably, I would say, the most important topic, actually, that you would need to know to really do well on them. But I believe that is it, and we're done.